Hey everybody, I had myself muted. I was like, no, I know I'll mute myself at the end of stream sometimes. How is everyone doing? If you're here, it's your turn to ask questions, to work on whatever you want to work on. Who all is here? Mubot is here.
I am Mubot.
Is anyone in the chat? Morning officer hour is pretty busy, I think. Yeah, sure. What do you want to talk about BS320? Kayla, you're here first. You get to ask the questions. Then we make the list of things we're going to do. Kayla, whatever you're wondering about, let me get 320 opened up right here. It is always open to everybody. Clarissa, good to see you. So Mubot, good to see you too, Mubot. You're always so positive, Mubot. Let's talk about some 320. Let me get over here to the 320 screen. Make sure everything's good to go. Chapter 7, feel free to ask whichever one you're working on, Clarissa. We will do that next. So whichever one you're working on, let us know, and we will work on that problem next. Q5 on the homework. Awesome. Yeah, the homework stays constant, so we can do Q5 on the homework. You got it. We'll take Kayla's 320 question here, and while Kayla's coming up with that question right here, let's go ahead and bring up the My Pearson. So I'm just going to get it loaded up. So, and thank you everyone for swinging by, and for those who watch later. So good practice. We're here to practice, learn the assignments. I just saw my review by my department. It was good. So I got some positive stuff right there. So it's got far exceeds expectations. Yes. It's like, good. That's what we want to get. I was like, yay. Here we go. Preview. And we'll see. We'll get chapter 5 loaded in the background right here. Question 5 is loaded up. We'll do that one here in a moment. Let's take a look. In the all correlations function, is it R or R squared that is listed? I believe it's R. So we'll talk about the all. I'm on the screen right now, right? Yeah, on the screen. Good. It should be R. And let's go over here and take a look at the all correlation function, part 3. And so here's where we're running the all correlation function. Remember, I sometimes do things differently than what we're doing. And this is a good review for 201. And there's the all correlations function. And let's go right here. You can put in any survey you want or any data frame you want. So let's do survey 11 today. Now this, as it would say, gives us all the correlations. And it's important we look at the output right here and we see that the very top thing it gives us is going to be the correlation value right here. So these are all values of R. And I always hate how the SciPen does that. So we're going to change just for the moment, we're going to change the options on SciPen and put it to 9. So it shouldn't click in the SciPen till 9 digits. So we do get the p-values here much easier to look at. So you can actually see the p-values. Is this making sense? But my R indicates barely any correlation. Yeah, why would that be? So let's sort this. Why would it be? And this is a good 201 concept that we get into at the end of the semester. We talked about it a little bit in 320, but why would it be that sometimes you get correlations that are pretty weak but statistically significant? The correlations, like all these right here, are statistically significant but very weak. Oh no, Cameron, you got it. We're going to do all the review. So I think I might do some review tomorrow too. So start using the videos, start going over it, look at the practice test, look at the Canvas content quizzes. You got it, Cameron. You got to look at the Canvas content quizzes and be like, okay, if I can do the Canvas content quizzes, I can do the test because the test is built from the Canvas content. So I think, interestingly enough, Kayla, Stat 201 notes might be really helpful with this. I'm going to pull up some Stat 201 notes, which we'll see here that when we look at the correlation, we can have statistically significant correlation, but I want you to look at this plot right here. Is this plot right here statistically significant? So find the p-value in this output. We probably need our lecture screen to see it better. Boop, boop, boop. Oh my gosh. Oh, gotta do this. You can do it? There we go. And there we go. Find the p-value in this buffering like 10 seconds. Is everything? Oh, it did blink. I see. That's happened every once in a while. We should be good now. So sorry, Kayla. I don't understand why it's doing it. I'm probably going to switch back to OBS. But I think the stream hit like a hiccup because it did the thing where the chat appeared. So I think we're good now, Kayla. Are we good now, Kayla? I think we're good now. And that was like one of those random stream hiccups, which we haven't had any other ones today. Yep, the p-value right here. So hopefully that I saw it on my end too because the chat reappeared because it like reconnected the chat. So I think the stream actually kind of crashed for a second, actually, to tell you the truth. It disconnected from like YouTube for a second. Not good. We don't like that. We've been relatively low on issues lately. So we see nice drop right there, Clarissa. So does that mean that this correlation is significant or is not significant? Is this correlation significant or not significant? We should know that pretty instantaneously. So the correlation right here is this value. This is like a 201, 320 review. There's the correlation value. So I always try to bridge the gaps between the classes. Oh, and the p-values, I think we just had another hiccup, everyone, and I'm really wondering what's going on. We probably just had do we have another hiccup? Because the chat did its thing when we see these hiccups. Come on, YouTube, or whatever's going on. I think we just hit another lag burst. Let me type it. Yeah. I saw the chat do its thing again, and I have no idea why it's done that twice today. And it didn't do it during class. Class went perfectly, and morning office hours went perfectly. So this would be very statistically significant. When is a p-value statistically significant? Good review right here. When is a p-value statistically significant? It means what percent the students think they're smarter than. So we ask the students, like, we're not lagging. Good. So that'd mean what percent think they're smarter than other students. So this is a good way to remember it right here. It's this 0.05 standard we use. I hope that's the last one. Sorry about those. I don't know what's YouTube doing. So less than 0.05. So this is the statistically significant region. And this is the not significant. This is where we're going to bridge the gap right here. So any p-values above 0.05 or at 0.05, at or above 0.05 is not statistically significant. Great questions right there, Taylor. Excellent work. And so above 0.05, at or above 0.05 is not statistically significant. So Kayla, now this is a big question. I want you to look at this correlation, get ready to see it. And I want you to tell me, is this correlation weaker or stronger? I just want to hear, is this correlation weaker or stronger? So look at this correlation on the screen right here, and is this correlation weaker or stronger? And this will lead into your answer to answer the question you originally asked. Is this correlation weaker or stronger than this one? There's the correlation here. Is this correlation weaker or stronger? Good stuff for stats one also. Is this correlation weaker or stronger? So is this correlation we see at the top of the screen weaker or stronger than the last one? Is it weaker or stronger? So here's the last one. There's the correlation. So is it weaker or stronger? Go down, remember, it might change your video quality. So it might have changed your video quality. So there's the, click the bottom of the screen where you can change the scroll wheel because you can go to HD. So it should still be in HD, but sometimes when it reconnects, it'll change the video quality on you. It'll downgrade it to like 480 or something like that. So there should be a scroll wheel at the bottom of the screen all the way on the other side, and you can upgrade the video quality. So, and why is it weaker than this one? Can anyone explain why it is weaker? This is great 201 review. Awesome. So why is this one right here? Why is this weaker? Go ahead and try to explain conceptually. Oh, good. I'm glad we said that, Cameron. I hate that some people, if people ever said the video quality is so bad on YouTube, I'd be like, no, click the HD wheel. I know. So much perfectly clear, right? Correct. This is -1 and +1 are the strongest. Closer to 0 is the weakest. So always remember that correlation goes from -1 to 1, and then 0 is the weakest. So the closer you are to these ends of it, the stronger it is. So these are the stronger areas, and then towards the center at 0 is going to be like your weakest area. So something weird right here. Why is this one right here stronger and this one's weaker, but this one right here, is it more or less statistically significant? Now, they're both statistically significant, but when you look at this right here, this p-value right here, which is statistical significance, because this is the p-value right here, this is the p-value, the probability of our results. Is this one more or less statistically significant? So here's the first p-value. Oh, we can do that one, yeah. We're going to hop back to chapter 5 here in a moment. Great question, Robert. So is this p-value more or less statistically significant? More or less? Here's the first one. Here's the second one. Is this one more or less statistically significant? Yes, Kayla, you're 100% right. The second one is more statistically significant. So how could a weaker correlation be more statistically significant? Like this one is a stronger correlation, but it's less statistically significant. This one is a weaker correlation. It's still strong, but it's weaker than the last one, and it is more statistically significant. So there should be something kind of obvious when you look at that. Versus this one right here. There's something that we call statistical power. And one component of statistical power is how big is the size of your what? And you'll notice this is what's going on right here, which controls kind of the ability to find results, which is statistical power. We mentioned that at the very end. The second one has a lot more data, exactly. So if you get a lot of data, sometimes you can find something that is very, 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 very statistically significant, but is not very what, Kayla? This goes now right into 320. Sometimes if you have a ton of data, like you have 100,000 observations, you might find something statistically significant. Great job right there, Cameron. You might find something statistically significant, but it's not what. Just by virtue of having so much data and so many results to analyze through, you might find something statistically significant, but it might not be this. And that's what you're seeing with your correlations probably if you're getting weak correlations. You're like, well, it is statistically significant, but it might just due to the large sample size, and it's not very what though. Because you can find things that are statistically significant, but not practically. Exactly. So when you're seeing these low correlations, you're saying, okay, well, this is statistically significant, but it's not really of any practical significance because the correlation might be like negative 0.04. And you're like, there's really close to no linear relationship, but what we are seeing is unlikely by random chance via 0.05 standard, but I'm not sure if this has any practical implications for what we can utilize it for. So that's does this make more sense, Kayla? And larger sample sizes are more likely to lead to statistical significance just because it'll pick up on things. Small differences are easier to find. If you have a small sample size, then it's harder to find significant results. Oh, yes. Yeah, we should do a 320 Kahoot tomorrow. We might do like a combined Kahoot. What if we do, because 201's going to have a big Kahoot on Sunday with $50 grand prize. We'll do a big grand prize for our test Kahoot too. Don't worry. I'll send out announcements about our test when that's approaching. But we'll have a big, but we should do a Kahoot tomorrow. Maybe we'll do a combined one. That'd be really fun. And I'll try to combine the topics of 201 and 320 into concepts like output and stuff like that. I think that's a good idea. Tomorrow, let's do a combined Kahoot, and we'll get everybody involved. And then we're going to do the big Kahoot on Sunday, which 320 can participate in. So big Kahoot. My husband raised an interesting question. Who buys these gift cards? Who's got two thumbs and buys gift cards? This guy. I do make, if you ever see an ad on the YouTube channel, I do make a little bit of money on the YouTube channel. Let's just say I don't make nearly enough to offset the game, but it's all right. I want people to have fun, and I just, I think it's fun. It's fun to win something. And if one day, 5-10 years from now, someone's like, "Oh, I was in your class and I won a gift card and it was a lot of fun," I'd be like, "That's awesome." If I can make someone's day by giving them a $20 Amazon gift card, thank you, Clarissa. It's, I want people to have fun. I want people to be like, "Oh, I won the gift card, yeah," or "came in second, yeah." A lot of fun. That's what we do. My mom, real quick on this, and then we'll head over to 201. You're welcome. You're welcome, Kayla. My mom was a teacher, and she would always like buy candy or stuff for her students. So I kind of just, have that example of a teacher who, wanted to, just you spend. A lot of teachers will tell you spend some of your own money. And I will say this: UT treats me very well. I'm really lucky. We got the orange in the background right here, Haslam College of Business. So I'm really lucky with how much the Haslams have supported us. You got President Boyd, you got so many people at UT, Dr. Galbraith, my department. I'm just giving shout outs to everyone. When I say UT supports me, I really mean it. I literally have a home studio. Last thing on this, I'm literally running a studio in my apartment with my fiance. So we have a dedicated bedroom to the home studio right here. So it's really nice, which I think I've shown that. Here, I'll show it again real quick right here. Where is it? I'll show you the home studio, then we'll do some 320 seriousness. And we're also going to get published, it looks like. Here is the latest. We'll go straight to, so we'll go over to 320 after this. I'm working on a paper, which huge thank you to Dr. Lowe of MIT, who I just, I hate writing, and he just, my gosh, I've never worked with people at this caliber. Like, this paper he wrote is over 60 pages. Insanity. Okay, so here, let's go over and we'll take a look at this. So it's going to be my first publication. Very exciting stuff. Because, let's do this here. You got it, Cody. After we stick this, we're going to do some 201. So this is the paper we're working on, the published paper. And this is the home studio I'm working with. And they even let me add in the Mario mug. So 21 right there. Mario mug, priceless. So I love it when I get to add in the Mario mug. But this is what I currently work from right now. So you can see the tablet in front of me that I'm touching right here. You can see the microphone to the right of me. And then the screen, I'm always looking at this screen when I'm lecturing. So that's why I'm always turned at an angle. There's the camera, there's the lights, there's another camera, there's the board. We haven't used the board that much this semester. There's the soundboard, there's the stream deck, there's the video changer, which I don't have 2 cameras set up. Anyways, that's what's going on. Let's head back over. And this is the world of, he called it World of Edcraft. So it's like World of Warcraft, World of Edcraft. But let's get serious here. Let's go over and do some assignment. Question 5 was the first question, and then we'll do Cody's, it looks like. Could you please go over the question about the advertised prices cars? Yep. I've been attempting this problem for the past 2 days. You got it, Cody. We're going to do this one right here. Then we're going to do the advertised prices of cars. So in this problem right here, we are predicting people's math scores from their verbal scores. So with the math score right here, you can see the math score is the prediction. Now, remember, interact with this. We got this. Everything you see on this line right here is all a what? Notation-wise, what is everything on this line, which we didn't mention today on our notation thing. Everything on that line is a what? We didn't put over here. Everything on the line, I forgot one thing today, is a what? I knew I'd forget one thing. Probably forgot another thing. Everything on that line, this is the notation we wrote down this morning. Every single thing on this line is a what? Every single thing. You bet. You got, we'll do Cody's, then Robert, you got it. Oh, Robert, I think you asked first. We'll do Robert's first. Everything on this line is a what? A what value of y? All of these are what's values. No one knows? No! The line makes what? The line is always making these like estimations. When we do a residual plot, we'll set the line to 0. So you might be thinking about residual plots right there, Clarissa. Let's draw some points. The line is called the line of best fit, and the line makes what? The line makes what for the points? Like the line is going to make what's, and here's the hint. Let's go back to the thing. The line is going to make what's. The line is going to make what's for the points. So it's the line of best fit, and we use it to make the line is going to make per... I hate saying the answers. No! The line is going to make... See, when I'm in person, I can just look and like... Line's going to make... Well, so the line... Good question right there. So the line will not be the exact values. The line... And we'll be doing this next week, so there's a really good review for 320 also. The line's going to make the predictions... Exactly. The line's going to make the predictions, and then the dots are the exact values. So this dot right here is the exact, like someone's exact math score. They made 800 on the mathematics, and they made about a 250. So this is the actual. Going by the notation right here, we see that the y is the observation or the actual amount, and then the y hat is the prediction. So everything on the line is a prediction, and these are the actuals right here. Like every dot is what someone actually made, and this is the model that would be used to predict their values. So what we see right here is a positive relationship, and people who score higher in one generally score higher in the other. So you just have to look for the positive and for the higher. Next we see, are there any students who don't fit the overall pattern? QQ straight enough, no outliers. So we definitely see an extreme outlier right here. QQ, 2 quantitative variables, straight enough, straight line goes through the data. No outliers, ooh, that's bad with the no outliers. Plot doesn't thicken, we're good on. This person who made a 250 verbal and an 800 mathematics, just tracing up right here, 250 verbal, 800 mathematics. That is the outlier we're looking at right there. Next, we see the R is this. Now, we can take R and turn it into what? What can we do? We can take R, and we can take R right here and turn it into what? I just turned this into what? I took R and turned it into what? Let me answer the rest of the question. I took R, so let's take R again. And that's correlation. So we have correlation right here, which tells us there's a positive, somewhat linear, there's an outlier, but a positive, somewhat linear, moderately strong correlation. And then I'm doing what to it right now? I'm doing what to it by doing this. I'm turning it into what value? I took R and I turned it into what? So let's look at here. Here's R. And then here's R something. So what are we turning R into? We're taking R and we're whatting it. We're taking R and we're squaring it. Nice job there, Callisto. Thank you so much, Clarissa. We're taking R and we're squaring it. And we have an interpretation for R squared up right now. R squared is the percent of variation in Y explained by the variation in X. So when you think about this, we're saying that 36.5% of the variability in somebody's math score can be explained by the variability in their verbal score. This one right here talks about it being above. So the important part to note is that the above mentions that there's a positive relationship, that people are scoring above. So there's a positive relationship. And then the one that's behind my head right here, 36% of the variability is the interpretation for the R squared. Blank percent of the variation in Y, so the Y variable was mathematics, is explained by the variation in someone's verbal score. So the R squared is what we're calculating right here. That is the value of R squared. So it doesn't say calculate R squared, but it does do an interpretation off of R squared. Now this part right here is where we need to use the solver. Can I take a screenshot of this today? Will it let me? Let's see. So here we are. We have the screenshot. The solver is located. I think I still have it up. So 2 seconds, class is not over. Okay, the solver is located, because we're going to use the solver. So please email me if you're in another class, you can't get the solver. The solver is going to be located in any of my 3 sections. We'll go to the asynchronous for now. The solver is located under modules. I'll make sure it's here. We'll go down to chapter 7 and you will see the regression solver right here, Regression Solver Pro. We already have it up today and here it is. Here's the regression solver and we're going to copy this in so we can read it while we do it. And here's the trick. They don't put correlation in this. They don't mention the correlation again. Oh, it's so crazy off the screen. They don't mention the correlation because they mentioned it earlier. There we go. So the correlation for this question has to be obtained from right here, which the correlation is 0.604. 0.604. So the correlation, which is R, is 0.604. So now we have the verbal score, which was X, and that's the average of the X variable, which is the mean. Yes, that's the X. So 49.99, 499.9. The standard deviation of the X variable is 178.1. The mean of the math scores is 496. And the standard deviation is 174.8. And now we have it. So I think we did everything correctly. I just want to double check. We are predicting mathematics scores. And so that is the Y variable. And there's the standard deviation of the Y variable. And here's the mean of the X. Here's the standard deviation. We entered it in. So we should have it. This should do it. And this makes life way, way easier. So everything right here that we're doing, as long as we put everything in the right way, it sounds like I'm saying incorrectly, but as long as we put everything in correctly, there we go. Let's check. We've done it. We've done it. So the homework one on this definitely lets you practice to make sure you can do it correctly because there is sometimes a quiz version of this. And it gets a little tricky right here. I wish that they gave you the full interpretation. The interpretation of the slope would be for each 1 unit increase in somebody's verbal score, we'd expect their mathematics score to increase by 0.539. So for each 1 unit point increase in their verbal score, we're going to see an increase. The other one says decrease. So the increase one is right because there's a positive slope. The next one, predict the mathematics score of a student with a 723 verbal. Very important right here, to predict, all we do, since X is verbal, we go right here and we take the equation and we just plug in the value of verbal. Whatever it says for the verbal score, which I think was 723, we plug that in. And if it was 723, which maybe it was, maybe it wasn't. It was 723, we just plug that in. But guess what? Regression solver to the rescue. There you go. There's the prediction, and it solves it for you. It's just solving the mathematics, which I guess I copied it, but 723 times 0593 plus 199.655. And it carries out more digits. I think it says round this to the nearest whole number. So 628, that would round to. And let's see. Round to the nearest whole number, 628 Either way, it rounds to 628, and we got it. The last one right here is a really tricky one. Yeah. Ask about task 2. You got it. I think we got 2 more questions here. You got it. Then we'll do some task 2. We got more than enough time right now. Thank you for showing up. We got this. So this one says every year a student scores a perfect 1600. So if you score a perfect 1600, which there's 2 sections, what does that mean you made on your math? And what does that mean you made on your verbal? If you score a perfect 1600, what does that mean you made on your math? And what does that mean you made on your verbal? If you score a perfect 1600, what does that mean you made on your math? What does that mean you made on your verbal? Yep. You got it. What does that mean you made on your math? I think we got 2 more 2-on questions, then we'll... What does that mean you made on your math? And what does that mean you made on your verbal? What does that mean you made on your math? And what does that mean you made on your verbal? If you make a perfect 1600... what did you make on your math, and what did you make on your verbal? So we're predicting someone's math score right here. Yeah. If you want to send it, feel free to send it. And great work, everyone. What does this mean? If you make a perfect 1600, someone makes a 1600, what did they make on their math, and what did they make on their verbal? What did they make on their math, and what did they make on their verbal? If they make a perfect 1600, what did they make on their math, and what did they make on their verbal? Any ideas? Oh, no. I see. I am stuck. I do not know. It's a sad day. I do not know the answer. I do not know. There's 2 sections. This is where people usually get stuck on this when they say, well, wait a minute. So there's 2 sections right here. If they make a perfect 1600, what did they make on their math, and what did they make on their verbal? Calzone. Here, I'll give you a hint. There's 2 sections. Calzone, thank you so much to the rescue right here. Well, there's 2 sections. So they made an 800 on their math. So if they make a perfect 1600, what did they make on their verbal? Calzone, the legend here to help us out. So what did they make? Clarissa, yeah. And so if you don't know, feel free to say you don't know. That's perfectly fine right there. I like that. And Kayla's offering some huge... Kayla, thank you so much. Kayla, we're throwing 50 points here. People interacting, helping out. That's what makes it. Clarissa, you're 100% right. The other one would also be 800. Nice job right there. Like, just Calzone. Calzone literally coming in saying, I don't know. And that's quite all right to say. I'm just going to slam the pencil down on the desk. That's quite all right to say, because then it's like, yeah, let's figure it out. So there's 2 sections, perfect 1600. So what do you think we can solve for right now? If we have this equation right here, what do you think we could solve for? We could solve for the what? And this is important to 320 because you'll be doing this. We could put this value in right here. And what are we solving for now? We're putting this value in right here. And what have we solved for now? I'm going to go ahead and solve for it. Exactly, Carissa. And what are we solving for? So we're solving for the what right now. By putting this in, we're solving for the what value. And you're exactly right. We're just going to put this value in. And what is y in this case? What is y? You're totally right. It is y. So Kayla is awesome. What is y? Like, what did we just solve for? And this goes back to the very start of the question. We're solving for y, and y is what does this hat stand for? Their and it'll be, so this is their math score. They actually made an 800, and then this is their predicted math score. Does that make sense? The small difference with the hat. This means predicted math score right here versus their actual math score. So this is what they actually made, and this is what they were predicted to make. And what are you hearing when I say actual and predicted? You should think of something. We have this residual wrap, which in notation is going to be, so residual wrap, y equals, oh my gosh, my brain broke. E equals actual minus predicted. So right here, you can see the notation, and the mathematics score is their y score. This is their actual y. And so we can solve right here. They actually made an 800. And so they actually made an 800. And they were predicted to make a 647.055. and that'll be their residual. Does this make sense right here? Everyone, thank you so much for all the positivity and the help. It really is just like, I tell, it's so interesting to me. Like sometimes like the person, like sometimes people will be asking for help, then a week later they'll be helping everyone. I've seen it so many times in 320, 201, where like someone comes to office hours, they're asking for help, and then just the next week they're explaining it. I think I did everything correctly, right? Woo! Got scared there. I think we have 2 more 201 questions, then we'll do some 320 because I know some big questions there. Which one was it? Remind me. Robert asked, can we do the question with the calcium and the mortality? We haven't done that one yet, so that's a great one to do. So let's look at the calcium mortality question, and we'll do one more 201, then we'll hop around a little bit. Calcium mortality question. Calcium mortality. That sounds like an amazing question, doesn't it? So it's about the calcium in water and the mortality rate of certain countries. And so we're going to pull up the quiz. You going to do it, my Pearson? You going to show us the quiz? My Pearson's being weird. There we go, my Pearson. Thank you very much, my Pearson. So let's go to replace questions. And there we go. We got it. Let's find the calcium in mortality. It's got to be near the end, right? And wildfires. We did wildfires yesterday. And let's go ahead and take a look. We did this one earlier today too. And no, maybe we didn't do that other one. Classified ads. Oh, good, Clarissa. That's perfect. Tell me, did I miss it? Wait, is it only on the homework? Did I miss it, or is it only on the homework? Unless I'm missing it. I just skipped it. No, tell me the number. How did I miss it? Here it is. Number 8. Awesome. Okay, let's do this. So with this question right here, oh my gosh, you guys are awesome in the chat helping each other on 320. I don't have major concerns with these plots right here. If you look at this, it looks to be 2 quantitative variables, Q, Q, straight enough. I don't really see outliers, and I don't see plot thickening. So it is negative, so it's definitely not positive. That eliminates this one. Negative, fairly strong, negative, linear between towns with, okay, let's go right here. Harder water is defined as more calcium in the water. So towns with harder water tend to have lower mortality rates. So when your water is harder, that means you have more water in it. Like hard water has high calcium. So they're saying this is harder water. So you have to know that for this question, that towns with harder water, behind my head right here, the harder waters, these tend to have a lower mortality rate. So you have to know harder water means more calcium. So random side knowledge right there. This gives you output like we would see in JUMP. Oh, that's awesome. Good job helping each other out, guys. I really appreciate that. Here's the regression analysis on mortality and calcium. And what you'll notice is this looks a lot like we would see either in R. We were doing this earlier in R earlier today. We totally lost that output. But we were also doing it in JUMP. So this table of output you see right here is just like, let's take a screenshot of this. It's going to be just like this output right here. So this is a very good question in that regard, that you can see this output right here. You've got the estimate of the intercept. You've got the slope right here. So this is, let's highlight the slope. These are the values we need. We need the intercept estimate. We need the slope. So this is B0 right here. This is not the same output, but it's the same format. And it shows significance. Like this is the significance of the model. Like that makes this model statistically significant. Who would feel comfortable seeing this on the test? Stuff like this could appear on the test. Would anyone feel comfortable knowing that this is the intercept? This is the estimate of the slope? We don't do much with the standard error in this class. We will in the other class. And the t-ratio is basically a z-score. So you don't really have to know in detail about the standard error and the t-ratios, but hopefully this output makes sense here because this is B0 and this is B1 right here. So this is the intercept and this is the slope. So we're just going to take, and I think it just wants us to directly copy these. So it's just like, do you know what this output means? Like, do you understand that this is the intercept, as it says intercept, and that's the estimate of the intercept? This is the slope because that's the x variable, and we put this right here, and we can't forget the negative. So hopefully this output makes a lot of sense. Interpret the intercept in context. So the intercept is when x is equal to 0. We expect y to equal b0. So, oh, the slope, haha. The slope is for each 1 unit increase in X, we expect Y to increase by B1. So X right here is calcium. You can see it on the X-axis. So for each 1 unit increase in calcium, the model predicts an increase by this much in the mortality rate. Explain what the y-intercept means. It's when calcium is equal to 0. So the model predicts that when a town with a calcium of 0, it predicts a mortality rate of this right here. So I would say when calcium is equal to 0, the model predicts a mortality rate of 1,661.789 for the mortality rate. My gosh, it's a big question. The largest residual was 89.4. Explain what this residual means in context. So what do we know about residuals? A residual that is positive must be where? A residual that is positive must be where? Anytime we have a residual that is positive, it must be where? So here's the calcium. Here's mortality. So anytime we have a residual that's positive, a residual that is positive must be where? This is a good review for 322. We'll be doing this very soon. Anytime we have a residual that's positive, it must be where? All positive residuals must be what? All positive residuals must be what? So here's... Oh, I think we just did the glitch again. Someone's going to say... Pretty sure we just lagged again. Yeah, Kayla's already saying buffer. I noticed it on my end. I'm glad it's just... I'm hoping it's not happening for class today. Sorry, everybody. I don't know why. Above line, exactly. This is the positive residual zone. This is the negative residual zone. And everything on the line would have a residual of 0. Like, well, that's not on the line. I noticed it on my end because the stream thing does like a reconnect thing. And I do not know what's going on. Like, I'm going to start Googling with YouTube. And last semester, we had like next to no issues. It was like, if we had an issue, it was like, well, that's weird. And then this semester is like, why are we having issues? Like, oh, sorry. So we have here that this is a positive residual. This is negative residual zone. So what does this mean? It means that the mortality rate is higher than the calcium would have predicted. So the large residual, the town had 89 more deaths than the model would have predicted. Oh, they're being specific. It's per 100,000. Okay, so it's got to be this one. The town had 89.4 more deaths per 100,000 people than the model predicted. So they're doing a context thing. Are you in our 320 Discord, Taylor? If you're on the Discord, there's just different channels. Make sure to go to the choose a role thing. And so you have to make sure to choose your role. If you can't find it and you message me, I can make sure you have the role assigned. So make sure you have selected the role. I think some people forgot to do that. And then they're like, oh, there's just a general chat. But if you can't find it, message me or put in the general chat. Like, it's easier if you message in the general chat. Like, hey, put me on the 320 Discord. People have been so active in the Discord lately. Like, I'll go and I'll look at 9. I'll be like, wow, everyone answered all the questions. I'll just be like, great job on that answer because that's right. So 320, keep it up on the Discord. Kayla, have you found the Discord to be beneficial? I want 201 to maybe one day, like, for us to have as strong of a community as we have this semester in 320, because the 320 Discord is getting to be a pretty strong community right now. Like, and I think people are utilizing the TAs more and more. They're like, oh, wait a minute. I can just meet with a TA. Like, I can be like, hey, can you answer some questions? So there's a lot of good availability for help with the Discord. And so thank you. Message the 201 TAs. Well, if you're in 201, message the 201 TAs. The hardness of a town's certain water is 111. Use this equation to predict. So we're just going to go up here to the equation. We're going to plug 111 into X. So let's just go here to the equation. Put it right next to it. 111. And we have to subtract. And we subtract. And that's the prediction right there. That is the prediction for the model. And 3 decimals. Good. Explain the meaning of r squared. Blank percent of the variation y is explained by the variation in x. We can't forget that we have our r squared interpretation right here. Yep. Oh, and then if you're not in the 320 Discord, let me know. Send me an email because the links expire. So I'll send out a new link. We don't put the link in the chat. Well, links would be expired anyways. Just because we would hate for someone to like join our Discord. And do we make new links? Yeah. If you can't find it, let me know. So 42.5% of the variability in mortality rate can be accounted for. Wait, what's the difference between these? Oh, What? Oh my gosh. Oh my god, what we do? The last one's right. What did we do? Whoa. Oh yeah, the last one is right. But what did I do today? Did I take a number down incorrectly? Wait. Who sees it? I've done so many models that what did I do? It was this one. Man, it's so easy to make mistakes. It's so easy to make mistakes. And I probably said increase anyways. It's so easy. This model's got a negative slope. This model's got a negative slope. I got that one wrong because I misread like 100%. Very easy to make a small error on these. The slope is negative. So when you look right here, the slope is negative. Don't get caught off guard by that like I did. I read it too quickly. The slope is negative. The difference between these and these are the negative slope. And I might have even said increase when I was talking through it, because the general way I say it is for each one unit increase in x, we expect y to increase by b naught, or b1, excuse me. And it is a negative slope as indicated right here. So definitely big error right there. Awesome. I'm glad people are finding it. There was one more question. Man, I need more coffee. Where's the coffee at? So what was the other one? People had one more, then we'll do some 320. What was the other question people had? What was the other one? If you can put the other question people were wondering about. And let's see. Man, I'm off my game this week. Usually I only miss, I can't remember what quote 3 is. Usually I only make like one mistake, maybe a week, maybe 2 a week. Just Vols help Vols. Thank you so much, Vols help Vols, right there. It's the stream making mistakes. It's so much easier when it asks you to interpret yourself. Like if I can just do a written response, I'll look to see if the slope is negative or positive. But when you have to do it, so 201, what was the other one? 201 wanted us to go over right here. So we did the calcium mortality, and then what was the other one? I'm pretty sure there was one other one. I don't see it in the chat. So 201, this is your chance. Could you please go over the question about the advertising? Yes, totally. Okay, we're going to get 100 on this one. Let's do it. Is it, yep, here it is right here. Advertise prices for used cars. And you know what? I love this one. You know why? Because we're doing it in Jump, and Jump makes life easy. So let's go ahead and go to easy mode Cody right here and do this in Jump. We're going to click this button right here. It's going to bring up a data table. We're going to click this second button right here. You're welcome, Robert. Thank you so much. Positivity. We all make mistakes. It happens. We're going to go to copy to clipboard right here. We're going to copy this to the clipboard. So copying it to the clipboard is going to allow us, make sure it's tab delimited, Control C. There we go. We copied it. And then we're going to go over to Jump. And inside of Jump, we're going to go to File, New Data Table. File, New Data Table. Under the New Data Table, do not click anything inside of it. Just full screen it for the moment. And then go to Edit, Paste with Column Names. Edit, Paste with Column Names. Where's Edit, Paste, Column Names? There we go. Edit, Paste with Column Names. Once you're here, you will see that they are blue. If they are red, you did not paste with column names. Start over. Make a new data sheet. And then paste with column names. Make sure they are blue. If they are red, you've made an error. Just restart. Don't use the red ones. Don't fix it. It takes more time to fix than it's worth. So now we are predicting the price of a car based on the age of a car. We're going to go to here to analyze, fit y by x. This is going to plot a y variable and an x variable for us on the same axis and allow us to fit a line. Here we go. We want to see if the age of a car explains, it's the explanatory variable, the price, as in why does a car cost a certain amount. We click OK, and then we go to the red arrow and we go to fit line because we're going to fit the regression line through it. So let's take a look at that. We do not need the analysis of variance section. We won't talk about that in 201, nor the lack of fit. It's going to be a high p-value. Of course it is because it's a good fit. We won't talk about that in 201. So with this right here, we have all the output and we should understand what's going on. When we get this regression equation, I want to point something out. This right here is the y hat. It's the predicted value of y. This right here is b0 in the regression equation. It's the same value you see down on the bottom here for the intercept. This value right here is b1. b1 is going to be the value of the slope, which is right here. And this is the name of the x variable, which is age in years. So just so you see, this is the equation right here. Let's go ahead and I think we can just remove this linear fit, but you'll notice, let me just go to fit another line. And I think we did this yesterday and I thought it looked pretty good. Can I make that still appear? To make it way smaller. Oh, wait. Look at that. There we go. So you can see both equations at the same time, that this is y hat. Y hat is the price advertised. We're predicting that. That's what the hat stands for, not just y, but y hat. You can see right here B0. B0 is the value of the intercept. B1 is the value of the slope. And then the x variable is age in years. And they're also found down here in the output, with the value of the intercept being right here, the value of the slope being right here, and the name of the x variable being right here. So what does this question ask? Now that we have all the output needed to solve it, the question asks us for, what is the equation? Well, we have the equation. So as long as we don't make a typo, we won't make a typo today. We won't. Not today, my Pearson. Not today. You've already won today too many times. So probably the best thing to do is to copy paste. Do not forget that that slope is negative. That's where I'm going to make the error if I'm going to make an error. Round to the nearest integer is needed. Well, that's a nice round. And let's go right here to the next question. Oh, that's going to round up. And then you have to make sure to put in the negative. Do not forget the negative value. Rounds up. And we should be okay on that. Explain the meaning of the slope. Explain the meaning of the slope of the line. Select the correct choice below. So it's going to be for each 1 year increase to the age of the car. So for each 1 year increase in the age of a car, the price of the cars, the model is going to decrease, don't make the mistake I did, by this amount on average. So we could say it increases by a negative. Great job right there, Kayla. Kayla, you're almost at 10,000 points. That's insane. That's awesome. So glad to see that. Explain. I want to see who's the leaders at the end of the semester. And I'm just so proud. Like, it's just so awesome. Explain the meaning of the y-intercept. It's going to be a brand new car because it's when age is equal to 0. So when age is equal to 0, we would expect the price of a car to equal a certain amount. The y-intercept is always when x is equal to 0, which is age. Don't change. So the y-intercept is for a new car, and we expect it to cost this much on average. So we go right here. The y-intercept means that a new car of this model costs this on average. We would expect that. If you say expect, that means on average too. These are our, yep. And then we go down here. This, if you want to sell an 8-year-old car, what price seems appropriate? There's a trick. Let's see a trick. This is a trick you can do at jump rather than solving this equation. Let's use the equation because jump might give us too exact of an answer. And I'm going to check to see if jump would do it. We're going to go to an 8-year-old car. We're going to times it by this right here. We're going to not make a typo. There we go. There is the price that the equation would predict. And I'm going to check it here in a moment. You have a chance to buy one of 2 cars, and let's say these are the same exact car. Would you rather buy one with a positive or negative residual? We're going to say it's the exact same car, and we already have a graphic up for this. Would you rather buy a car? Here's car A or car B. So would you rather buy car A or car B? And we'll pretend it's the same car. It's 2 dealerships, and here's price, and this basically gives it away. And this is age. So they have the same age, and we're going to say it's the exact same car, not like one's better than the other. So this is the exact same car. Would you rather buy the one with the positive or the negative residual? It's the exact same car, like identical. It just happens that it's being sold in 2 places for some weird reason for 2 different prices. And would you rather have the one with the negative or the positive residual? The answer here should be very, very clear. So unless you like to spend money, unless you're like, I just like to spend money. See, someone could say that. We had one time asked a question. It was about like your neighbors, and someone it was like, and you'd want to choose the option to be nice to your neighbors. And someone's like, what if I don't like my neighbors? I think we had someone who's like a really good student, like purposely wrote an answer that was like the reverse, but had the right understanding, but they purposely like did a what if this is true? Which we're like, oh, that's an interesting answer. Are we all super buffering? Hopefully it's just on your end, Sarah. We had a few issues where it buffered randomly. We did chapter 7 homework part 5. We did question 5 at the very start of the stream. Check out about 15 minutes in and we can go back and check it out. We're probably gonna do a little more 320 right after this. Is it working now decently, Sarah? I hope we're not having like any major buffering issues. I think I'm gonna switch over to OBS this week. I'm gonna get it set up. It's weird. We just randomly have issues as of late. There was one week where it was really bad. And I don't know if it's like internet in Texas is going on. We definitely want the negative residual right here because it has a much lower price than we would predict. So the car with the negative residual, because its actual price is below what we would have predicted right here. You see this is a long question. You see a for sale sign on a 12-year-old car and the asking price is $9,000. What is the residual? So this is the actual price of the car. Let's go ahead and take the information we need to solve this. This is the actual price of the car, and we need to get the predicted price of the car. So the actual price of the car right here is this value. This is the actual value, which is Y. That is, no, my computer has been messing. Oh, okay, good. I guess more people are on campus. Yeah, hopefully that's, sorry, we've had a few issues today, so it could be on this end. You never know. So now we need to get the predicted price. To get the predicted price, what are we going to do? We're going to plug 12 in for age right here. So we're going to go right to this equation and plug 12 in for age. 12 times 797. And we are finding the predicted price right here. This is the predicted price. So it's really close, isn't it? Was it a 12-year-old car, it said? So 12-year-old car. And it looks like it's going to be very close to it. I think it was selling for 8,000 or something. So the actual minus the predicted. And yeah, so let's just go that we got it right. So the predicted price is equal to 8098. So to get the residual for this, we have to do residual equals the actual minus the predicted. Residual equals actual minus predicted. And so we just plug in the numbers. We've got that the actual is 9,000 and the predicted is that. And so it should be 902. 10. So let's just double check our work. Actual minus predicted 902. There we go. The residual is 902, which is how much we miss. Already did it there. Deja vu. So we go right here and we go down 902. Would this regression model be useful for predicting a 25-year-old car? And the answer is no, because the model only goes to 11 years. No, this would not make sense. No, because it would be negative. I think also you can see this with the regression model we made. It just wouldn't make sense. It'd be like, this car is free. So you could bring this out to 25 and take a look. That's the cool thing about Jump right here is you don't even need to solve it. You can actually visually see that at 25 years, you would have a negative number that the model predicts. So, and there's other ways in Jumps to solve this also, but we should have it right now. Yes, that's our redemption right there. Awesome stuff. Of course we got it. We know what we're doing. My Pearson can't trick us. My Pearson can never trick us. I think was there some 320 questions or Sarah, if you have questions, let us know. Stretching. Take a stretch break right here. What questions are there? I think Thacker had quite a few questions. I don't know if Kayla answered them all. What questions are there right now? 320, 201. The floor is currently open. I know Thacker had some. So Thacker and I think we had another 320. The floor is currently open. So Taylor, I think we might have sent where the FCA said, can you go over task 2? You bet. Thank you so much, Thacker, for hanging out. Let's talk about task 2. Let's do this. Thank you everyone for, with 2 different classes, I try to like divvy up the time because we did 320 at the start. Cody, so glad to help out. And we just we hop around between tasks and we do all the work. You're welcome, Alexis. So good to see you, Alexis, and everybody. It's funny because sometimes I'm talking and then I don't even know some people are watching who are like, oh, wait, I'm working on this question. So thank you so much for swinging by, everyone. Let's throw some 20 points to the chat. With this task right here, we are going to see whether or not a test is statistically significant and whether or not the p-value is inclusive. So in this test, let's go ahead right here and look at the associate output. So in the associate output, let's do it in a chunk that we should be doing it in. So, we did some of this earlier. So let's take a look at this code and first understand what this code means. So this code right here does what? You can say, I don't know. I don't know is a fine answer, which I'm not even using this right now. What does this code right here? And I'm going to change it to the following. This is not quite your assignment, but this is the theory behind it. So don't copy down everything I write. I'm always talking about the theory and doing things similar. What does this code right here do? What does data do? Because I'm probably going to switch it up for the next assignment, like on how we do it. What does data do? What does data do? What does the function data do? So it's like preloaded video games that are installed on your computer. It loads these up. So there's a whole bunch of data frames that R has access to that are installed into R. And these are all the data frames that are like pre-installed. This is not like reading in a file. These are all kind of in the background, hanging out like Swiss. So you can go right here and type Swiss, and you can load up the Swiss data frame, and now the Swiss data frame is loaded in. Yeah, exactly. So this is data that is like, and this is not like an Excel file. Like if you want to read in a file, you have to go to read CSV. So you can read in an Excel file here, which I don't know if I have something called like data, but if I did, you could load it in, and we'll just call it data frame. Do I have anything called data? Nope, I don't. But if I did, it would load it in. So this would load in and save this to a data frame right here. So this would read the CSV file, and the CSV file's name is data.csv, and would store it to something called data frame. And if this worked, it would load in. So there's quite a few ways to get data into R. This is actually a very important thing to know. And a lot of people, I think, don't realize loading your data is one of the most important things to know. We're not always working with preloaded data. So this is just like a preloaded data set that's already here for us. What does the following command do, the attach command? So the attach command makes vectors available in global environment. So I like to use the attach command. It just makes life way easier. It's a quality of life thing. So if we were to clear out the global environment, and I don't think we should have access to these anymore, do we? Oh, we do. You have to go to unattach. You have to unattach them. Is it not unattached? Am I going crazy? Oh, there it is. Ooh, that's interesting. Will it work? I thought it was unattached. I have lost my mind. Oh, detach. Ha ha ha. Okay. Good. So, okay. Got what we need. So this loads up the data frame, and as you can see, it's just one way to load in data. It's not how we always load in data. As you can see, when I run the data function right here, it loads it in. This is not quite what you're doing, but we need to know what these commands do. This makes it so the vector is available in the global environment. So now when I run this, the vector is available in the global environment because the vector, the height vector, is in the data frame. But now it can be ran via the global environment. And the great thing also is you get autocomplete now, so it'll autocomplete the vectors. We love autocomplete. I had the same thing happen today in RStudio. Told me it could not find the function associate. So if it can't find associate, where is associate located? Where is associate? And there's a hint on the screen. Where is associate located? These are great things. These are great things to practice. Thacker, great work right here. Let's throw 20 points. While we think over where is the associate function located? Where is the associate function located? Where is the associate function located? And there's a hint on the screen. Where is the associate function located? So there's a hint next to it. Where is the associate function located? So where is the associate function located? So if it says it can't find function associate, why is that? You have to load in reg class. So the way to load in libraries, which it's at the start of this file, I can't speak today, is you have to load the library reg class, and that will load up all the libraries, or that'll load up the reg class library. So like if I want to use something like ggplot, you see I can't right now do plotly. Plotly is a function I want to use, but if I go to library plotly, now when I go here and I go plotly, we get the plotly functions, because now all of these plotly functions are loaded in. This is another way. I never use this right here. I'm not a big fan of this format, but some people do this to call like an individual function from like, I just never have been a fan of doing this right here, to call functions like this. You can call a function this way, but I don't like doing it. I just didn't train myself to do that. This is just how you load the whole library. It's probably if you're doing a whole bunch of coding, maybe you just want to call one function from a library instead of loading everything. Okay, with this right here, we've got the associate function right here. What is the formula right here is y tilde x comma data equals, and that's the name of the data frame. We have the permutations we're using, which is how many permutations we're running, 100 permutations. And then we have the seed. Why'd you call that? Whenever you did the code that begins with QQ, how did you call it? You can just go right here in QQ, and you could do something like this. Oops, sorry, it's way too small. With the QQ function, it is a quantile plot, and the QQ function will make a normal quantile plot. So the QQ function, what's a bummer about this one, it's so short, it won't autocomplete. So since it's so short, it doesn't have an autocomplete on it. Like you can type QQ, but it won't autocomplete, but then you can see it, the function's been correctly called. Does that make sense, Thacker? That the function right there is a QQ normal quantile plot. It's so short that the autocomplete doesn't kick in. The autocomplete kicks in after, I can't even think. What am I thinking of? I'm thinking of summary. Like after 3 letters, you get your autocomplete. No, good questions right there. After 3 letters, you get your autocomplete. So QQ is only 2 letters, so you don't see the autocomplete kick in. So with this right here, if you were to type 3 letters here, you get your autocomplete, and then usually you type a few more just to get the more precise, because it'll start narrowing down. You get a lot more with this, then you start narrowing down to the associate function right there. So summary, I usually type about that much, or you can type the whole thing, and then it autocompletes. Visualize model. See, there you go. I think because if you type viz, you get other ones, but there you go. It just keeps eliminating down. Oh, no worries. Autocomplete. I wish it would kick in after 2. I wonder if there's a way to do that. I wouldn't mind if it kicked in after 1. I don't mind. I'll bring up everything that starts with 1 letter and then 2 letters and let it keep sifting through. Maybe it's too much, like too processor intensive, because matching everything with 1 letter is, you're not really narrowing down the results enough with 1 letter search. I wonder, it should do like a most recent search though. That'd be really cool. Maybe with updates to RStudio, you never know. So this is the format right here. How many, and then, so we need to put in a XY relationship or YX relationship right here. Y is the variable of interest. We were just talking about this in 201, and X is the explanatory variable. You don't have to do your code like this. I just like to make my code look nice. It makes life way easier. We'll look at the example we were looking at earlier. So let me go back in time. Back in time. There we go. Your code could look like, not the end of the world if it looks like this. Every year I try to make myself better at coding. And if you look, which of these looks better, version 1 or version 2? What do you think, Thacker? What looks better, version 1, which you can say version 2. You'd be like, I like it all to be 1 line. Right now, you should use a seed. Right now, the seed is not specified. The seed is what right now? The seed is what? If you see capital NA, what does capital NA stand for? Like here's a vector. And what is in the first 2 spots in this vector? I agree with version 1, Bradley. I think it looks way better. So, and then what does NA stand for? NA stands for those values are what in the vector. So the values right here, if I put NA for seed, that means the seed value is what? So I'm running this without a seed, basically. That's the long and short of it, is there's no seed. Little bits. Oh, man, let's throw some 50 points right there. You know how to code in little bits. Yep, it's little bits. I like that right there. That's what we're always trying to do. Little bits. Coding in little bits. That's the way we do it. So never try to do the whole thing at once. It makes more sense to kind of look at it in parts. Like here's my formula. Here's my data I'm loading it from. Here's the permutation amount. And here is the seed I'm using. So I think it really helps to just see it in smaller little bits. Oh, man. If only Rick and Morty knew they would be used for a statistics class. If only they knew. I think we found a seed today that worked for this. Nope. Was it 201? Oh, man. Well, I'll be. The seed is not working. The seeds are not working. I've been watching too much Deadwood. Talking like I'm on Deadwood right now. Oh, man. We can just not get... We cannot get a not conclusive interval for the life of us. Oh, my gosh. I don't want to cheat too much. Wow. I got some earlier today. Oh, it's gotta be the variables I'm using. Did I used to see variables earlier? I'm looking at the plots down below, and I think it's the variables. I think I changed my variables. I think I had different variables. Yeah, I think it is way shorter. I know last week was a much tougher assignment. I'm always trying to be reactionary. So good to see you, Charlie. How are HDT, Thacker, how are you guys feeling about this assignment? Is it feeling better? Because last assignment took 2 weeks, and I wanted this one to be shorter. I'm always reacting to how long people work. That's why I'm always asking, like, how long did this assignment take? If it's too easy, I'm gonna so don't always be like, oh, that was such a hard assignment, Brad. That was the hardest assignment ever. We are completely stuck. Oh my gosh. There's no way we did change the variables. That's why. Yeah, we had different variables here to begin with last time. Okay, now it'll work. I was like, I just am not getting. Yep. Okay, good. Yeah. Okay, we're good. Good. No, yeah, that's the descriptive stuff is super important, and that's what's really important is we want people to, and make sure you're doing all your own work. It's okay to talk to people. It's okay to work together. Don't send whole things of code. It's all right if you send like a small screenshot or things like that. Don't be sending like whole files, because then you could run into the risk that someone could copy your file. You just don't want to be the one. You don't want to copy, and you don't want to be the one who gets copied. So you want to help each other in a positive way. So you can share screens and stuff like that, but you don't want someone being like, hey, can you pause here while I type this all down? You want to explain things like I'm sharing my screen, but then I don't send out like, here, just take all this work and do it. You have to then work through it, and I try to do examples like it. But I think there's really great ways for students to positively help each other out, and that's our goal, is that we want students collaborating. We want you to work with another student. We want you to get help from people. We want you helping people. You just don't want to, say to someone, here's the work, just change this and change the words here, because I mean, unless we give everyone unique assignments, there's no real way to say, and that what would be the point of that? It'd be so hard to make unique assignments for everybody. The only thing I'm trouble with is task 2 to find 2 variables to get my. So there's a kind of a trick for that. We're using the trick. How could you make your interval wider? Which this is an acceptable way, and this really makes life a little bit too easy. I hate to say too easy. How could you make your interval a lot wider? Which is a good conceptual thing, which someone mentioned, I think, in the Discord. How could you make your interval a lot wider pretty quickly? So HDT and Thacker, how could you make your interval a lot wider pretty easy? And I've done it here. You got it. Decrease the permutations. Which this one right here, if you use this variable right here, if you use text per day and gender, it looks like this is, I think it's 500 by default. And by default, it would not be, but with 200, it's close. With 100, it is. And you notice right here, this interval is inconclusive. Now, it's maybe worth mentioning that in these results, we should always know, should we use the means or medians for this? Should we be analyzing means or medians here? So it's worth mentioning. Oh, Selena, that's not good. Let me go look at the YouTube channel. Oh, please tell me the YouTube channel is not broken. Something crazy. Something weird happened this morning with it. It looks all right, Selena. Okay, now my channel's glitching a little bit. Oh, okay. Yep. I think you're right, Selena. Maybe I got an email and it says the whole channel's been copyright striked. The whole channel. Okay, I don't see anything from YouTube in my email. Now live on your channel. Okay, good. Hopefully it's just a YouTube thing. Ha 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 ha. I'm clicking YouTube thing. Ha ha. And I'm laughing right there. This is morning office hours. You might have to click to the video list. I think it's a currently YouTube thing. Is there a video you go to? Okay, it's working-ish. Okay, it looks to be working. Might be a momentary glitch thing. No, that's all right, Selena. Which video are you looking for, Selena? I can probably link it in the chat. I think you might have to go to the links for the videos. There might be something weird because it was acting a little bit weird. How do I get my plots to look like that? After I run my function, they should look like this. Well, like, are you looking for the morning office hours? Are you looking for a certain class? I'll send you a link to it, and you can tell me if clicking the link works. Might be just some weird thing with YouTube at the moment. That's happened too. Man, semester's just crazy. So with your plots, office hours for chapter 7 quiz. Okay, I'll put that one. I'll link it in the chat for you. There was weird stuff this morning. I think we did it February 23rd. Okay, this video has a lot of... tell me if this link works right here, Selena. Yeah, the 23rd, cool. Does that link right there work? Try that link. And Thacker, is your stuff... And everyone's correct. Sorry, I got distracted, everyone. Taylor and HDT, you are 100% right. This would be medians 100%. So although we can say that the interval for the mean is inconclusive, we could say, with that said, we would still analyze medians, but it is worth noting that the interval for the means is inconclusive. So did that one open, Selena? Maybe, hopefully Selena might be on that video now. And we did do some chapter 7 stuff here earlier. What other questions are there? Sorry, got a little... Everyone, no, good questions. I hate to think you two saying. Got it. Awesome. Glad to help out, Selena. Glad to help out, Selena. You're welcome anytime. Just drop in and be like, hey, this is not working. Especially if I'm live right here. So one time I had someone email me and they're like, Brian, you didn't respond to my emails. And I waited all day. And they emailed at like 1 p.m. And I was like teaching until like 7. And then I replied back at like 7:30. I want to be like, I'm sorry, I was teaching. You're welcome, Thacker. Anytime. Because he's comparing quantity. Yeah, exactly. That's why I'm doing like a different one. So I don't always do the exact same ones. Oh, you're saying, we're throwing 20 points right there. Yeah, because he was saying his output doesn't look identical to mine. Amazing job right there. Taylor points out, no, I didn't even realize the question. You get different, but no, like great job pointing it out. Because when we do things like height and weight, we're doing 2 quantitative variables, and now you'll get a different output. So thank you so much, Taylor, right there. You understood the question better than I did. I was just thinking it was, how do you get this output? But the question was specifically, how do I get like this out? Like you're getting this output, I'm getting this output. And then we should know that this is when we're analyzing a categorical X and a quantitative Y. And this is when we're analyzing 2 quantitative variables. So very important to see the small differences. Now, what is the only one? Alexander, good question right there. I have a question on number 4 on the quiz. Put in part of the question, and we'll do that next, Alexander, because it changes what the questions are. What is the only other graphic we have not seen? We see here side-by-side box plots. Here's side-by-side box plots with histograms. And here's a scatter plot. What is the only other graphic we haven't seen? And this has been a huge review. What is the only other graphic we haven't seen? And this will be a huge review right here. What is the only other graphic we haven't seen? Because we haven't done an analysis of that yet with this data set yet, just on this part. What is the only other graphic we haven't seen? Here's a scatter plot. Here's permutations in a histogram. Here's side-by-side box plots. Here's histograms. Here's QQ plots. What is the graphic thing we haven't seen to analyze 2 categorical variables? If you're analyzing 2 categorical variables, what would we use? Well, we haven't done logistic, but to analyze 2 categorical variables, and logistic, for anyone wondering, would be a categorical Y and a quantitative X. So you got it. Burgers, fat, and calories, you got it. And we haven't done a stem and leaf, but with the, that is true. How about, we haven't seen right here, mosaic, Thacker, great job, mosaic. And there's the mosaic plot. Now tell me, are your results conclusive or inconclusive here? Are these results conclusive or inconclusive when we look at this p-value? So we're trying to estimate the p-value here, and we're saying, I think the p-value is about 0.76 for gender and handedness having an association. And so are these results conclusive or inconclusive here? Really good practice. Are these results conclusive or inconclusive? Do we have a graphic up for that today? We don't. Oh, no, we do. Conclusive HDT, you're 100% right. Because when we do this, an interval is conclusive, and our interval right there is basically about this interval. An interval is conclusive, and we have conclusive intervals in green. So these intervals right here are conclusive because they conclude whether or not something is statistically significant or not. When is something inconclusive? When is something inconclusive right here? An inconclusive interval, which means it cannot come to a conclusion. Something is inconclusive when, and all these intervals down here are inconclusive. All these green ones are conclusive. It doesn't matter if it's above or below. It just cannot what to be conclusive. An interval must be what to be conclusive. And if an interval is inconclusive, then it would what? If an interval is inconclusive, it would be what? We could do a very, very tiny interval like this, and that interval right there is inconclusive. When is an interval inconclusive and when is it conclusive? And so that interval right there, that like the one I just drew right there, that could be that interval. Like 0.04 to 0.079 would be inconclusive. So that would be an inconclusive interval, and why? Anytime an interval is inconclusive, like it cannot conclude whether something is statistically significant or not, it contains 0.05. We want the interval to be entirely above, like this one, or entirely below, like this one. It can be a wide interval. It just has to be entirely below or entirely above. It cannot include 0.05 inside the interval. So if it's entirely below, good. If it's entirely above, good. If it includes 0.05 in any way, like these intervals here include 0.05, I could make them conclusive if I moved them up here. I'd have to change the color, but those would then be conclusive intervals because they don't include 0.05, so they would conclude a result. And let's look at the fat and calorie burger one. Yes. See, you guys are going to make me want some burgers. Man, I have not. I mean, we've had some good burgers. Like Chelsea and I made some awesome burgers here, but I would love to go out, go to a great restaurant, and just get an amazing burger. That'd be awesome. We've had good food, but, like, I don't know. Just nothing beats going out to, like, a burger place and getting, like, chili fries and, like the best fries, really quick on this. I like fries that, not the really, really thick fries, but I like fries that have, like, a good amount of potato in them. Like, they're crunchy on the outside, just some good, like, thicker fries, not like steak cut, but, like, in between steak cut and McDonald's fries. Like, man, that'd be good. He's like some good cheese sauce on them. Oh, cheese fries and everything. Oh, you guys are killing me. I'm killing myself eating cheese fries. So, yeah, we'll do the Wildfires one next. You got it. So we see right here, we have fat and calories. So this model says, explain why you cannot use this model to estimate the fat content of a burger with 600 calories. So they're trying to estimate fat, but they're saying that they made a model to predict calories. So this model was made to predict calories from fat, not the other way around. Oh, cheese fries are... man. See, it's like as an adult, I mean, when are you an adult? You can eat cheese fries every day. That's when you're an adult, when you can eat cheese fries every day. And some adults choose to eat cheese fries every day, and I'm jealous of those adults because I want to eat cheese fries every day. I don't have cheese fries because I would eat them every day. I was going to say you're an adult when you can eat cheese fries every day and you don't. Oh man, crinkle fries, like the spiral fries, who has those? Are those at Hardee's? No, like who has the really spiral fries that they put the seasoning on? They're like orange, like the fries are like a radioactive orange. Oh, so good. I think it's Arby's. It's Arby's. Those some Arby fries right there. You're talking about crinkle fries, maybe like waffle fries. Just wondering if there's a video for Visualization 5. You bet, Wesley. Checkers, yeah, Checkers is good fries too, and Arby's. Yeah, this is what we're talking about, Wesley. Visualization 5, we did that. Let me send you the Office Hours video for that one. Visualization 5 was done towards the start of this week. The YouTube channel is acting weird. Oh, that's really awesome. Thank you, YouTube, for making our channel act all crazy. Okay, wait. Don't break the channel, Brian. Don't break the channel. Okay, good. But I think we did it. And then we'll do this problem right here. Do we do it in the morning? Did we do it last week? February 18th? When did we do Viz 5? I am losing my mind, everybody. Weekly device, visualization 5. Oh, wait, here it is. I got it. Good. Got it. I know we did it this week. Viz 5. Viz 5, full walkthrough of Viz 5, full walkthrough of Viz 5 right there, Wesley. Full walkthrough of Viz 5. Okay, let's go ahead and take this and bring this over to Jump because Jump's gonna make our life way easier. Copy to clipboard, copy, there we go. Use an appropriate model, estimate the fat content of a burger with 600 calories. So we need to then put this into Jump right here. Jump's gonna make our life 100 times easier with file, new data table. We're gonna then paste with column names. Don't forget to paste with column names if you're watching this. You're welcome, Wesley. This is probably the 20th times I'm telling everyone, paste with column names. There we go. Don't paste without column names or you'll get this. This is a bad day right here. So we're gonna close this off because we're not gonna do that. We're going to paste with column names, not paste without column names. Bad, red means bad. And then in this instance, blue, because blue is quantitative, blue means good. So we have pasted with column names right here. We're going to go to Analyze. We are going to predict why a burger would have a certain amount of fat from the calories. The calories are going to explain that. We're going to go right here. We're going to hit the red arrow and go to Fit Line. And now we've fit the line through here, and we do not need the ANOVA section. We just need this model predicting fat from calories. So there we go. Let's go ahead and look. We're just going to copy paste. Copy paste is your best friend. There we go. I'm going to delete that minus and rewrite it. 3 decimals right there. And let's go grab the last bit of that output. And here is the output right here. Let's talk about fries all day. I like statistics about as much as I like fries. I mean, fries are awesome. So, you know, it's hard to like anything better than fries. So the fat content of a burger with 600 calories is, we're just going to plug right in here to this. Oh, wait, the fat content of a burger with 600. It should say predicted. Come on. We noticed that yesterday too. It should say the predicted, not the actual. It makes it sound like actual right there. Another thing I need to contact my Pearson about. So 600 calories is going to get plugged in right here. We're going to times that by this right here. There's the value there. And then we're going to subtract, because this is a negative intercept, 18.721. Then we're going to drag drop. We're going to delete down to 1 decimal. We're going to get a 100. Of course, we get the 100. There we go. Oh, Bradley, thank you so much. Glad to hear that. I think we emailed back and forth a little bit too between classes. Anytime you're stuck, email me. I'll always try to get back to them as quickly as possible. Really appreciate that. That's what we're here to do. We're here to help everybody. So hopefully I'm not too ADD, but I'm always like trying to jump around to be like, oh, let's get this person help. Let's get this person help. You should see the in-person office hours. They're a lot of fun. In-person office hours are like literally me bouncing around between like rooms and be like, hey, who needs help? And then I'll be like, okay, we'll do this. And I'll hang out for like 3 minutes. And I miss it. Like I would walk by one of the rooms and students would be like, Brian. And so like, I'd be like, 1 second, like, no, grab Brian, get him in here. And they'd be like, we need you for 10 minutes, Brian. And then another room would be like, no, we need Brian. Oh, it's so much fun. We'll be back doing that again soon when we can all be in person again. But we still have fun here. And so thank you, Bradley and Alexander HDT and Wesley, and good to see everyone here. So we got the Forest Wildfire one right here. Do you think a linear model is appropriate? Yeah, it's just weaker. It's just, yeah, they're straight enough. There we go. The relationship is straight enough, but not very strong since data points are very spread out. Linear is still appropriate. So the linear just matters if the line goes through the data, and the line mostly goes through the data, which is what we're looking for. Interpret the intercept of the model. The intercept is right here, and this is years since 1982. So when years since 1982 is equal to 0, we expect y to equal b0. So the amount of land damaged by wildfires, this is the intercept. Wait, oh, that's slope. Where's the intercept? Yes, the intercept represents the amount of wildfires at the starting point of 1982, the amount of wildfires that there were in 1982. The slope is going to be for each 1 year increase from 1982, we expect the amount of wildfires to increase by this amount. So it's going to increase, not decrease, not remain constant. So that's good on that one. This is the standard error technically correct? No, this is standard error, the residuals. But you don't have to know too much about this. All you want to know is, are these large misses or small misses? So I wish this question just said, are the residuals small or large? So when you look at these residuals, do they look pretty far away from the model or pretty close to the model? And the question kind of gives it away at the start with this answer when it says the relationship is straight enough but not very strong, so the points are very spread out. So the points being very spread out, which is something we should say here at the start, should coincide with this question right here where it says the errors the model make, which are the residuals, the amount of error in the model's predictions, residuals, that's the error, is quite large. This one says they're small, this one says they're large, and so the answer is that the errors are quite large. Explain the R squared in context. 23.7% of the variation in the land damaged by wildfires can be accounted for by the model's years. No, we don't include the other factors. Woo! We got it. Yay! Good to see you here, Selena. Did that help out, Selena, with the project and everything? I don't know if something weird is happening with YouTube. Please, YouTube. There was a whole bunch of like lag bursts that we had in this stream. Every once in a while, YouTube just does weird stuff. I'm gonna get my second cup of coffee here soon. What questions are there? We're finishing up office hours right now, but it's your time to ask questions. This is our time. Our time to ask questions. Feel free. So good. So glad to help out, Selena, right there. I'm gonna fall asleep. One day people are gonna tune in the stream. I'm just gonna be like, people go, wait up, Brian. I'll be like, what? But we might do. Finally got it to all to work. I know. I think something weird is happening with the channel. Like something weird was at the start of the semester where it actually wouldn't show when you click videos. It wouldn't show all the old videos. Oh, you're welcome. This morning I had to delete a stream. Also, it logged me out of Streamlabs. So I don't know if YouTube updated something, but it logged me out of Streamlabs. So I was really worried. Here, we'll hop to space. We'll listen to... I like this one, I think, a lot. Yeah, this one. We're not done yet. We're gonna hang out for a moment. Relax. Get some more dog tur coffee. Trust me. I'm a doctor. Coffee. Coffee. I know, it's interesting. Caffeine, is a drug. And it's totally something in our society. Isn't Brian talk about society? It's just like, I don't know. I've gone off caffeine for a little bit and you feel it. Like you feel when you're like, I haven't had caffeine for like a week. And you're like, man, I'll wake up in the morning. I gotta like do stuff to feel awake. I could just drink some caffeine. I could get to the video and then it would all go black and could only see the one video. Oh no. But now it's fixed. So everything's 100% by the time we get to class. One more class today. That's so weird that it worked when I sent the link. I'm so glad that sending the link made it work. Yeah, I haven't heard from other people. I might like my emails might be flooded when I get out, and like it might be like YouTube is not working. I'm like, ah. Let me look at the internet to see if anything's going on with YouTube weird. Oh, I just chill out here. Let's see. I just went to YouTube. 10 people watching, chilling out. That's awesome. News on YouTube. Are you utilizing YouTube in your business? Recent, past 24 hours. They're doing a new site for parents. That's everything what people are saying. Let's look in the past hour. Nothing going on with YouTube crashing. So it looks like we're good on that. You're welcome, Alexander, so much. Who knows? I mean, nah, I hope it's something like that. But it was kind of weirdish on my end too. It was kind of just, it was weird over here too. And then YouTube logged me out this morning. I deleted a stream because I made a, there was a few weird things on YouTube this morning. I hate it. They'll change things. They'll change how they've changed the studio. They've made a lot of changes since I started streaming on YouTube. So sometimes when they make a change, they'll break something. And maybe I'm under like an experimental group or something. So you never know. You never know. Maybe I'm in that group that they broke. They broke my YouTube. I paid tons of money for this. I know it's so strange. It's just like you wake up and then everything's all weird. Like, is that gray hair? I'm getting old. With that, we'll head off here. But we'll be back. Mubot. Fan favorite Mubot. Got anything to say to people today, Mubot? I know what you're probably going to say. I know what you're going to say. I know what you're going to say.
I am Mubot.
Chill out, Mubot. Until next time, Mubot, we'll be back. But bye for now, everyone. Bye.
I am Mubot.